Good evening, everyone. Today I am going to discuss about multi-resolution indexing in data warehousing. Fir- Firstly, imagine if you are browsing a digital map, you zoom out to see an entire country or zoom in to find a street corner. The level of detail adjusts to your needs, broad overviews or pinpoint precision. Now imagine applying this into the data warehousing. Yes, we are talking about multi-resolution indexing. In a world where data is exploding in size and complexity, traditional indexing like B trees, bitmaps can't keep up, especially with time series or spatial data. Whether you are looking at daily sales trends or drilling down into individual transaction, this technique makes querying faster and smarter. Let's dive into what makes this approach so effective and why it might be the future of data warehousing. Let's first we discuss about what is indexing in data warehousing. Indexing in data warehousing is the process of creating auxiliary data structures that speed up the retrieval of records from massive datasets. Traditional indexes like B-trees, B-trees indexes are great for range queries. Hash indexes work well for equality conditions. Bitmap indexes are ideal for low cardinality columns. However, these methods become less effective when queries target large, high dimensional data spaces. There's a need for both detailed and summarized data. The storage cost of maintaining detailed indexing becomes prohibitive. This gap is filled by multi resolution indexing. Multi resolution indexing involves building hierarchical indexes at different data resolutions. Each layer responds to a specific granularity level. Example yearly, monthly, daily. Queries are routed to appropriate levels based on the required precision. Now let's discuss about the key components of the multi-resolution indexing. Firstly, the first component is raw data layer. The raw data layer consists fine-grained timestamp data. Now coming to the intermediate layers, which contains aggregates over large intervals. Now coming to the topmost layer, which courses or summarizes the entire data. This approach supports roll-up and drill-down queries, which are similar to OLAP cubes and can be efficiently implemented in both batch and real-time systems. Now let's understand multi-resolution indexing with a numerical example. Let's consider a scenario of temperature sensor readings. Imagine a weather station records temperature every minute. We want to query this data over various resolution, that is minute level, hourly average, daily average. Now, the steps in multi-resolution indexing are: the first and foremost step is ingest the raw data. The system collects temperature readings every minute. The fine-grained data is stored in base level table or time series data, as you can see in the picture. Step 2: aggregate into hourly buckets. Every 60 hours, every 60 entries, the system computes aggregates like average, minimum, maximum, and min. Ap- Aggregate step 3: aggregate into daily buckets. At the end of the day, aggregate the 24-hour values into a daily summary, as you can see in the picture. This forms the coarse resolution layer, which will be the highest layer. Now, step 4: query routing based on the resolution. When a user issues a query, the system automatically selects the appropriate resolution layer, as you can see in the picture. For if we consider what was the average temperature yesterday, it will the access layer will be daily and so forth. Now, the final step will be efficient query execution. By routing the query to the layer with just enough detail, the system avoids scanning unnecessary data, leading to blazing fast performance. Now, the main important point in the multi-resolution indexing is each layer stores a summary of layer below it, which will be perfect for high-speed querying. Now, let's just discuss about traditional versus multi-resolution indexing. As you can see in the picture, the query speed will be very high in the multi-resolution indexing, and the storage usage will be very low when compared to the traditional indexing in the multi-resolution indexing. And also, there will be multiple level of details which provides highest flexibility, and also scalability will be very high in the multi-resolution indexing. Now, let's discuss about the use cases. Multi-resolution indexes is widely used in the current market. For example, IoT analytics, billions of sensor readings summarized into hourly or daily trends. Financial markets, traders analyze second level stock ticks, executives use quarterly aggregates, and so forth. Now, let's come to real world implementations of multi resolution index. Real world implementations include Apache Druid. built for real-time analytics with multi-resolution indexing. And the second one will be InfluxDB, downsampling capabilities for time series data. Google BigQuery supports table partitioning and clustering for performance. And the final one is Timescale DB, offers continuous aggregates for multi-resolution query. Now, these tools apply multi-resolution principles to improve performance, reduce cost, and support complex analytical use cases. Now, coming to benefits and trade-offs in multi-resolution indexing. Benefits include faster query response times, lower storage costs for aggregate levels, efficient data summarization, and trend analysis. Now, trade-off will be complexity in maintaining multiple indexes, potential loss of detail at coarser resolutions, requires careful design to balance resolution levels. Now, coming to conclusion, multi-resolution indexing is very useful for today's massive and dynamic data landscapes. It addresses the shortcomings of traditional income indexing by offering adaptive multi-granular access to the data. Whether you are querying across time series, logs, or spatial data, this strategy balances performance, cost, and flexibility. By adopting multiple resolutions, organizations can unlock faster insights, reduce operational costs, and build more responsive analytical systems. It's not just about faster queries, it's about smarter data access. The more scalable and adaptive your indexing strategy, the more power you have to explore, understand, and act on your data. Thank you.